All right, we're going to do this free response style question with Taylor polynomials and Lagrange error bound and kind of see how it can all tie together. So it says the function f has derivatives of all orders for all real numbers. Values of f in its first four derivatives at x equals 3 are given in the table. Write an equation for the line tangent to the graph at x equals 3 and use that to approximate f of 2.5. All right, so tangent line is y equals mx minus x1 plus y1. What this is a first order Taylor polynomial that we've been doing and we just don't even know it. Or we didn't. So I'm going to say f of 2.5 is approximately equal to the first derivative, so would that be negative 8, times the x number, 2.5, minus the point that we have of tangency. We have the point 3, 4. So minus 3 plus 4. This would be equal to, this is what, negative 0.5 times negative 8 would be 4 plus 4, so 8. So what we basically just did a first degree Taylor polynomial approximation, and we got 8. All right, well, it's just a tangent line approximation. All right, write the third degree Taylor polynomial for f about x equals 3 and use it to approximate f of 2.5. All right, so I'm going to write this out. The third degree Taylor polynomial at x would be equal to f of x plus f prime at x. X or c? Oh, I'm all confused. So we'll say x because, or the c is 3, right? So this would be f prime of 3 plus f prime at 3 times x minus 3 plus second derivative evaluated at 3 times x minus 3 squared over 2 factorial plus the third derivative evaluated at 3 x minus 3 to the third power all over 3 factorial. All right, so what I need is to plug in all those numbers. So the third degree Taylor polynomial would be equal to f of 3, so it's 4, plus the first derivative evaluated at 3, which is negative 8. So I'll say negative 8 times x minus 3. That's positive, so plus, this would be 14, but 14 over 2 is 7. X minus 3 squared. The third degree is negative, so negative 22 over 3 times 2 times 1 would be negative 11 over 3 times x minus 3 cubed. And then what do we want it to do? It says calculator active, so I actually want to plug in the number. So P of 3 at 2.5 would be equal to 4 minus 8 times negative 0.5, so it's 2.5 minus 3, plus 7 times negative 0.5 squared, minus 11 over 3, negative 0.5 cubed, and that is equal to 10.208. So the way I could write this is I could say f of 2.5 is approximately p of 3 of 2.5, which is equal to 10.208, accurate to the third decimal spot. Okay, but I actually have a calculator, so I want to plug this into the calculator and get the actual number. All right. Is there enough information to determine whether f has a critical point at x equals 2.5? If not, explain why not. If so, determine whether f of 2.5 has a relative minimum, maximum, or neither, and give a reason. All right, so in order to have a critical point, the first derivative has to be 0, and it has to be a maximum. It changes from, positive to negative. And then derivative has to change from negative to positive to be a minimum. But in either case, it has to be, the derivative has to be 1, right? To be a critical point, because it could have neither max or min, but still be a critical point if the derivative is equal to 0. Do we know f prime of 2.5 is equal to 0? I don't think so. I know f prime of 3 is equal to negative 8, but I don't know what it is around that. So I'm going to say no. The reason we don't know that f prime of 2.5 is equal to 0. All right, kind of a weird question, but anyways. All right, here's the good one. The fourth derivative of f satisfies the inequality. All right, so they're basically telling us the absolute maximum of that fourth derivative evaluated at x is 48. So if they're telling you that, they're telling you like this is Lagrange error-bound problem, and that's going to be part of what you plug in, even though we don't know what the derivative is. We don't know what the fourth derivative between 2.5 and 3, we don't know what it is. It could reach its maximum at 2.5, but we don't know. But it says for all values of x greater than 2, that fourth derivative max is 48. Use the Lagrange error bound to show the approximation found in part B differs from the actual function value at 2.5 by no more than 1/8. So kind of that the Brian Passwater question we did earlier. So I'm going to say the error using a third degree Taylor polynomial evaluated at 2.5 is less than or equal to the absolute maximum of the fourth derivative evaluated at z, where z is some number in between our center and our approximation number, our x number, times the x number, 2.5 minus the center to the fourth exponent, fourth degree, over 4 factorial. I know this is equal to 48. So the maximum here is 48. So that gives us that number. Times, negative 1/2 to the fourth power. We just said that was 1/16 in the last problem, or somewhere we did that. Over 4 times 3 times 2 times 1. Now I'm just going to simplify this a little bit more. And if I'm writing small enough, I would write this equal over there. But I'm going to say this is equal to 48 divided by 16. I think that's just 4, right? Yeah, that's just 4. There's no more negatives, so I'm just going to say 4. Over 4 times 3 times 2 times 1, which is equal to 1 over 3 times 2 is 6. And, looking at my paper. 4 factorial. 4 times 3 times 2 times 1. 4 over 1/16. Is 1/6 less than 1/8? I don't think so. Did something wrong. This is not good. 48, 4 times 3, 12, 24. 48 divided by 16. Is that not 4? Oh, that's 3. All right, so 48 divided by 16 is 3. Okay, I feel better. That would be 1 over 8. All right, there we did it. Because that's the number, right? It's no more than 1/8, and there's that. All right, so that was kind of embarrassing, but yeah, 48 divided by 16 is 3, not 4. All right, last one. What is the coefficient of the x minus 3 cubed term in the Taylor series for f prime? And f prime is the derivative of f around x equals 3. So coefficient, I'm just going to say p of x. So the Taylor polynomial, I'm not going to write what degree it is. I'm just going to do it until I see this. But this is a Taylor polynomial for f prime. So the first thing you always write would be just the function value, but the function is f prime, evaluated at 3. So that's like your f of x, but it's already f prime. Then the next one would be the second derivative evaluated at 3 times x minus 3, plus the third derivative evaluated at 3 times x minus 3 squared over 2 factorial, plus the fourth derivative evaluated at 3 times x minus 3 cubed over 3 factorial. So this one's kind of tricky because it's saying the Taylor series or the Taylor polynomial for f prime. So that's why we already started here. So our coefficient is going to be this part right here. The fourth derivative evaluated at 3 is 30 over 3 factorial, which is 30 over 3 times 2. So what is that? 5. All right, that's it for this video. Hopefully it helped, and thanks for watching. Bye.